this video, I'll introduce my first attempt at a bicycle generator. My initial interest in bicycle generators sprung from the need for an alternative power source in the face of scheduled blackouts following the March 11, 2011 earthquake in Japan. Using information found on the internet, I decided that the easiest thing for a novice to do was to hook a car generator, a car alternator, to a bicycle. I selected the Delco Remy CS-144 based on the fact that there was lots of information on the internet about it. It produced good output at low RPMs, and the remans are fairly inexpensive. What I did was I took an old mountain bike, removed the rubber wheel, and replaced it with this plastic tubing. On that, this belt will run, and the belt is connected, of course, to the 6-groove pulley on the alternator. This particular alternator is fairly easy to set up. There are just two connections. One is the S, or sensing connection, which is using this red wire, is connected to the positive terminal of the battery. Second connection is the L, or lamp connection, which goes through this 50 ohm 10 watt resistor, which will help to reduce the amount of current drawn when the ignition switch is turned on. The zip cord is run to the front of the bike where I have the ignition switch. While this is on, it'll draw power, which, following back the zip cord, power will come from the terminal, the output terminal of the alternator, which is also hooked to the positive terminal of the battery. So while the switch is on, it will draw current directly to the coil, and then when it reaches 14 or so volts, then the voltage regulator will kick in. It'll no longer draw current from here to power the field, but it will continue sensing whether the ignition switch is on. So the switch has to be on for this to generate power. What I've also done to monitor the RPMs of the alternator, I've moved my speedometer magnetic pickup here to the back wheel so I can monitor the speed. What I've done, taking the output, since it's going to charge the battery primarily, and there's more output available, I've taken the additional output by hooking these clamps and this cable to a grid tie inverter. And the grid tie inverter will take as much power as it can from the output and put it, of course, on the grid. So the output of the grid I put through this watt meter, and then it goes on to the grid. So one more thing about the alternator. There's a couple downsides to choosing this particular model. One is that the voltage regulator will not operate it without a battery in the loop. So if you try to use this just to connect to an inverter and power some appliance, it wouldn't work. You have to have a battery there, so it's always drawing at least some current in order to charge the battery. Second thing is that the stator coil here is configured in a delta configuration rather than a Y or star configuration. What this does is give higher output, higher amps at higher revolutions, but at lower revolutions, lower RPMs, it's a little less efficient. The third thing is that grid tie inverter, if you think about what it tries to do, it tries to draw as much power as it can safely from the power source without the voltage level dropping. Well, if you've got a voltage regulator maintaining voltage, then when the grid tie inverter tries to take more power, back at the alternator, the voltage regulator will continue to put out 14.4 volts by increasing the field strength of the coil. And what that will do is require more power from the bicycle. So this thing will continue, the grid tie inverter will continue to draw more power and will require more power at the pedals, and until my legs give out, and that's usually when I throw the switch and turn the inverter off. And I'll show that in the demonstration. Typically, if I was going to use a regular inverter instead of the grid tie inverter, I can maintain a sustainable power of about 50 watts. My max output has been about 150 watts, And if I use this as a interval trainer, then in a 40-minute session I can generate about 10 watt-hours of power, which isn't a whole lot. Well, I'll go ahead and fire up the demo and let you see what this thing does in action. Let me walk you through what you're going to see in the demo. First, I'm going to rev up the RPMs in the back to about 2,600 RPMs at the alternator, which would be about 33 kilometers per hour here on the speedometer. And then you'll see the voltmeter jump from 12.9 to about 14.7. Then when I know that the battery is being charged, I'll flip on the grid tie inverter, and that will start the sequence where it starts negotiating. You'll see the green LED flicker until it gets to some point where it thinks it's got a steady load. Then as it's gaining output power, what you'll see is the watt meter here climb. It'll continue to climb until it gets to a point where my legs can't sustain it, and at that point I will go ahead and flip off the grid tie inverter, and you'll see this go back up to about 14.7, and it'll continue to charge the battery until I flip off the ignition switch. So let's get started. I've got it at the proper RPM, so I'll flip on the ignition and push through the initial field blast. So now it's charging the battery. I'll flip on the grid tie inverter. You can see it negotiating, starting to generate wattage. And it'll continue to climb. And that's about the rate that I can sustain. I'll flip it off here. You can see that I'm charging the battery, 14.7 again. Flip off the ignition, and it goes back down. You can see the battery's surface charge, and it'll continue to go down to about 12.9 again. So if I do 15 to 20 reps of what I just showed you, it gives a pretty good workout. In a 3-month period, I was able to lose 5 kilo, 12 pounds, and improve my cycling average speed by 25%. But there is a better way, a more controlled way of using an alternator for a resistance trainer, and I'll show that in a subsequent video.